This facade is being demolished, and it is still one of the most important pieces of architecture of the last 50 years. Not because of how long it lasted, but because of what it unlocked. It was the first building with fully unitized, curved three-dimensional glass facade, one continuous surface, wall and roof at the same time. Before the City Hall, that shape existed only on paper. The Gherkin followed, then the walkie-talkie, one Blackfriars. None of them would exist without what was proved here. But City Hall left one problem unresolved, and every building that inherited its ambition inherited that problem too. My name is Eugene Korch, I practice and teach facade engineering, and today we talk about facade access and maintenance. Let me ask you a question. Your building is finished, people have moved in, 10 years pass, one morning a glass panel cracks on the 14th floor. How does the replacement panel get from the factory to that opening in the wall? It has to reach the site and travel up to the 13th floor. Think about it. The panel weighs over 350 kilograms. It is 3 meters tall and almost 2 meters wide. It needs to travel 14th floor up into the position on the outside of the building. Can you carry it through the building, through the lobby, into the goods lift, down the corridor, through somebody's apartment, and out through the window opening? On most buildings, the answer is no. The lift is too small, the corridor has 90-degree turn the panel cannot make, the apartment door is too narrow. Nobody checked any of this during the design. So the only option is to lift it from the outside. That means a mobile crane on the street, a road closure, a traffic management plan, a specialist rigging crew for one panel. And this building has 60 years design life. This will happen again and again. That is what happens when nobody plans the access strategy. A failure to plan today becomes a cost that repeats for 60 years. When we say facade access, we mean 4 things. First, cleaning the building. Second, inspecting it for defects. Third, routine maintenance. That means replacing seals, touching up surface finishes, fixing minor damage. And fourth, replacing components that have reached the end of their design life. In plain terms, it broke and it needs a new one. Every one of these tasks requires adequate access to the facade. That might mean a platform, a cradle from the roof, or a rope operative on a harness. Some of these tasks happen regularly. Glass might need cleaning 3 or 4 times a year. Ceiling joints need replacing every 15 to 20 years. That is 2 or 3 full replacement cycles during the life of the building. And here's the thing most people do not realize. Most of the facade cannot be reached from the inside the building at all. The solid wall between the windows, the area above each opening, the soffit of a balcony, the outer surface of the balustrade. None of that can be touched by someone standing inside an apartment. For all those surfaces, you need access from the outside. And that is where the real challenge begins. Let us walk through the options from the simplest to the most complex. The simplest tool is a long pole with a brush and a water supply. The operator stands on the ground. The pole reaches up. Modern versions can get to about 25 meters. That is roughly 7 or 8 floors. No ladders, no scaffolding, no machinery, just a person on the ground with a very long stick. Above that height you need a motorized platform. Some are self-propelled, others are vehicle-mounted. The most versatile has a joint arm that bends around obstacles like canopies and setbacks. The large ones reach about 55 meters. That is roughly 18 floors. Worth noting, this method is only effective for a light clean, removing dust from the glass. It will not shift serious staining or biological growth. For taller buildings, you typically need a permanent machine on the roof. A long arm extends over the edge of the building. A working platform hangs from the end of that arm. Workers stand on the platform and get lowered down the facade. When they finish one strip, the machine rolls along the track to the next position. And then there is a rope axis. A trained person descends on 2 ropes, each connected to its own anchor point on the roof. Very flexible, can reach almost anywhere, but it's slow and it needs a lot of safety management. And there's one thing it absolutely cannot do: carry a 350 kilogram glass panel. These are the most common methods, but they are not the only options. Other equipment and techniques exist, and the right choice depends on the building. Here's where the buildings get into real trouble. The roof is the starting point for cleaning machines and the rope teams. But the roof is also where the air conditioning units go, and the solar panels, and the ventilation equipment, and the satellite dishes, and sometimes a green roof as well. On a project after project, the mechanical plant gets placed right at the roof edge. That is precisely where the cleaning machine tracks needs to go. Nobody coordinated it. The clash gets discovered during the construction design stage. Fixing it at that point means delay and cost, or it may not be possible to fix it all. Then there are balconies. Every balcony blocks the vertical path of the cleaning platform. Every balcony is a private space belonging to a tenant. Every balcony has a surface that needs cleaning: the soffit, the outer face of the balustrade, the glazed screen, most of which cannot be reached from the platform or from the inside. And the machine itself is heavy. The unit on the roof might weigh 10 tons, and they counterweight the wind forces and the braking loads, and the total reaction on the roof structure can be over 60 tons. If the structural engineer did not know about this from the start, there is no capacity for it later. Now, some of this can be avoided if the building is designed so that the residents can clean their own windows from the inside or from a balcony. If the window is opening inwards and the glass is within the arm's reach from the floor, no external equipment is needed for that window. Glazing on a balcony can often be cleaned by the residents from the balcony itself. These are some simplest decisions an architect can make, but they have to happen early. Once the window type is fixed, the access strategy is locked in. Let us look at some numbers. A permanent roof machine is expensive to buy and install, but each cleaning visit after that is relatively affordable. Rope access is cheap to set up, just some anchor points, but every single visit costs significantly more because it takes much longer and you need certified operatives, rescue team, risk assessment and equipment hire every time. Over 60 years, the cheaper system to install often turns out to be the more expensive system to run. The exact crossover point varies from building to building, but on many projects the permanent machine pays for itself well within the first half of the building's life. But there is a catch, and we'll talk about it later. And here's the real trap. If the cleaning is expensive, cleaning gets postponed. Once you miss the recommended cleaning schedule, the warranty on the facade and on the glass can become void. And a voided warranty on a large building means the owner pays for everything out of the pocket. It happens all the time. And do not forget the disruption. Every time crew comes to clean or repair the facades, the pavement and possibly part of the road below have to be closed off. On a busy street, that means formal permissions from the local authority, complaints from neighbors and local businesses. Over 60 years, these disruptions add up to a significant burden on a building and everyone around it. Now I want to talk about something that has become one of the defining challenges of modern tall buildings. Architects want the roof to disappear. No visible plant, no mechanical clutter, just pure geometry from every angle. City Hall was the pioneer. There is no conventional roof. The facade wraps up and over. The fifth elevation, the roof as part of the architectural statement. Every building that followed, the Gherkin, the Facade, the Scalpel, the Walkie-Talkie, adopted the same idea: no visible roof, which raises an immediate question. Where does the building maintenance unit go? At City Hall, the answer is the timber shed right next to the building. It looks like a cafe, and it is a cafe at the front, but it's not why it's there. It's the permanent storage for a cherry picker used to clean the facade. The access strategy is literally a shed. The skyscrapers that came after learned from that. They internalized the solution. On the Gherkin, the motorized gated pit at level 36, called the garage, where the building maintenance units are stored out of sight. The Facade houses its units in the side of the building. The Scalpel, the Walkie-Talkie, and one Blackfriars all have integrated cradle systems built into the structure itself. Now, how much does one of these machines cost? Think of it this way. The most basic unit, a simple machine for a straightforward building, will cost you roughly what you would pay for a Porsche. A mid-range machine, the kind you will find in a typical residential tower, is a Rolls-Royce territory. A Ghost starts at £250,000. And the integrated systems on the buildings like one Blackfriars, and it has 3 of them, that is collectible Lamborghini money each. Now, when you buy Rolls-Royce or a Lamborghini, I would imagine you are expected to service it regularly. Oil, tires, all of that. To be honest with you, I'm not a car person and I cannot afford any of those vehicles, but I was told they also break down, and quite a lot. But here's the difference. When your car breaks down, you call roadside assistance, or you drive it to a garage. A building maintenance unit cannot be driven anywhere. It lives on the roofs or inside of the building. It has an engine and moving parts just like a car. Its design life is 25 years, and it must be maintained far more rigorously than any car, because unlike a car, it's suspended dozens or hundreds of meters above the ground carrying people. There is no roadside assistance halfway up the skyscraper, which means the access strategy for the building must include a strategy for replacing the machine itself. That's not simple, and it's not cheap. The Gherkin found this out. One of the BMUs in the garage at the level 36 needed a new telescopic boom. St. Mary's X is a narrow street surrounded by buildings that have gone up since the Gherkin was built. There was no room for the size of a crane needed to reach 160 meters. Closing the street for 2 or 3 days was not realistic in the heart of the city of London. The solution was a helicopter. Early in the weekend morning, St. Mary's X closed for 30 minutes. The lift took 5 minutes. Problem solved. But it required a helicopter, a Civil Aviation Authority permit, a specialist contractor, international partners, and months of planning for a component replacement on a building that was just a few years old. When you design a building, you are not just designing for today. You are designing for a BMU replacement in 25 years, in a city that will look very different by then. Plan for it now or pay for a helicopter later. This is just a 10 minutes video and we have only scratched the surface. If you want the full picture, every access method explained in detail, we run a detailed technical webinar that covers all of it. The link is in description. City Hall gave us something real. It proved that curved glass at scale was buildable. The buildings that followed are more ambitious because of it. But it also handed every building that followed an unresolved problem. Access and maintenance is a design decision, not an afterthought. Make it from day one.